This is a short movie about the Event and Applied Situation Ontology, developed during the NewsReader project. If you look at the general picture of NewsReader, then ESO plays a role in the annotation and extraction of events, as ESO types the events and roles affected. Also, ESO is used in Reasoner attached to the knowledge store. Here, explicit knowledge about the event is added, based on assertions in ESO. ESO is an abbreviation for the Event and Applied Situation Ontology. The ontology models the implications before, after and during an event, and models the roles of the entities involved. For this, it uses the output of the semantic role labeling. The ontology was built bottom-up. In short, we derived a set of frequent and salient FrameNet frames from the subset of our car data. These frames were used as a starting point for modeling the ontology. The SUMO ontology was used as a background model for grouping and structuring the frames. ESO is built as a separate model with mappings to SUMO and FrameNet frames and frame entities. As such, we don't have to adhere to the modeling decisions in these resources. Additionally, about 1750 manual mappings were made to print subordinate synsets. ESO is written in OWL and licensed with a CC BY same as license. ESO is applied in NewsReader to type the events. It defines, for instance, that some event is of the type transportation. Further, it models and defines the implications of events and roles of the entities affected by the event. The reason for building ESO was that we found millions of events and all kinds of lexicalizations with a huge variety of FrameNet frames and semantic roles. But we couldn't inference over these frames, as FrameNet was not built for this task. Also, we knew that something has happened, but not what the implications or pre- and post situations of the events were. Let's have a closer look at these event implications. From a sentence such as, "Apple hired Steve as the new CEO to save the company," a human reader understands a lot of information that is actually implicit. Humans directly infer this, but computers can't, unless it's made explicit. In ESO we make this information explicit. On this slide you find a non-formal description of the information that ESO infers based on this sentence. For instance, before the event, Steve was not employed by Apple. After the event, Steve is employed by Apple, and he has a certain function and a certain task. Making this information explicit allows us to derive sequences of states and changes over time, regardless if this information is explicitly mentioned in text or inferred by a reasoner. Such a chain of states and changes is presented in the picture. In the boxes you can see various event expressions. The blue ovals represent implications inferred by ESO. In the case of an expression such as Ian hires John, we infer that John did not work for Ian before the event and that he works for Ian after the event. This implication is also the during situation for the expression John works for Ian and the pre-situation of an expression such as Ian fires John. An important notion related to ESO is what we call simple semantics. So you may be fired, resign or quit your job, but in the end you no longer work for some employer. In other words, we abstract over FrameNet frames. You may be a FrameNet victim or a FrameNet seller, but in context of some change of possession, first you own something and now you don't. In other words, we lump frame elements. And you might travel to Bucharest while smiling over a certain speed, but in the end you're in Bucharest and not where you were before. In other words, we only use a selection of frame elements. In short, the ESO approach to event modeling is that we focus on modeling the implications of events, not on the semantics of the events themselves. In other words, we don't focus on formal definitions of what it means to increase, buy or steal, but only on the situations that hold before and after an event. Furthermore, we don't define all possible implications of an event, though the model is open to extensions. So, how and where is ESO employed in the NLP pipeline and the NewsReader Knowledge Suite? First, documents are processed by the NLP pipeline, including semantic role labeling. Based on the semantic labeling, predicate and role information coming from the predicate matrix is added. In short, the predicate matrix combines predicates and role information from various resources, such as FrameNet, VerbNet, and WordNet. Classes and roles from the ESO ontology are mapped to this predicate matrix. As such, the annotations in the documents are enriched with ESO classes and roles. Next, all annotations are stored as NUF files, and from these NUF files we generate the trig files that contain the extracted events and participants. All this information is stored in the knowledge store, where the ESO reasoner adds the assertions defined in ESO. Next, we illustrate how we get from text to instantiated ESO assertions by means of a simplified example. Consider the next sentence. John generously gave the book to Ian. The sentence is annotated with FrameNet frames and frame elements. For some of these elements, an ESO class and role will be defined. From these annotations, we create a named graph where we state that this event is of the type ESO change of possession, and the 3 participants are involved in this event. Further, the event is coupled with a timestamp. For the class change of possession, a set of situation rules is defined. Here, we look only at the rules for the pre-situation. For this pre-situation, 2 assertions are defined, assertion 1 and assertion 2. In these assertions, we define the actual pre-situation. Here we state that the owner number 1 has in possession some theme before the event, and that owner number 2 does not have in possession some theme afterwards. Next, we instantiate these rules with annotations for the sentence. For our example sentence, that implies that John has in possession the book before the event and Ian doesn't. ESO now consists of 63 event classes, divided over dynamic and static events. Further, there are 46 mappings to SUMO, 103 mappings to FrameNet frames. To define the pre, post, and during situations, we created 123 situation rule assertions. This was a very brief introduction to ESO. To find out more, we refer to deliverable 5.2.2. ESO.l and an extensive documentation can be found on the GitHub.